Hey, good morning, everybody. We still have a few people coming in the room, but we're going to go ahead and get started because we value your time and we appreciate you showing up for today's webinar on Predictive Maintenance 101. And we have with us today Dan Anderson, who's Product Manager of Components with Omron Americas. He's coming to us today from Hoffman Estates in Illinois. Dan, welcome. Dan has been with Omron for a couple of years now. He's an electrical engineering graduate from Valparaiso University in Valparaiso, Indiana. Correct, Dan?
Yep.
And we are going to get started right away, and we will respect your time and cut this off at around 40 minutes. Hey, Dan, one thing that we had on the flyer for the webinar was talking about these lead times that have been quadrupling in many cases. And I'm just wondering, as kind of a segue into this thing, how can predictive maintenance help with those lead times?
Yeah, that's a great question. Let me clear my screen real quick here as these notifications keep coming up. So as we'll kind of get into the presentation, we'll talk a little bit more about, like what is predictive maintenance and how can it help and why is it valuable and all of those things that everybody's probably here to learn a little bit about. But to kind of address your question directly, so one of the things that predictive maintenance does is that it, like I said, it predicts when your equipment is needing service or approaching a failure point, right? So if you kind of have a little bit of a prediction event, a heads up before something fails, as you mentioned, with lead times being extremely elevated as a result of all of the cascading effects from the pandemic, right? Product that used to be on the shelf, three-phase motors, a variety of sizes, used to be on the shelf and readily available, no longer are, right? So if you can have a product that predicts a failure of your equipment sometime in the future, any of that additional lead time between prediction and actual failure is all just gravy in terms of adding extra weeks before your process goes down, which gives you more time to basically find a replacement and install it. So great way to kind of pad your lead times on products that used to be readily available and no longer are. So
great.
That's kind of a good place to go on that one.
Yeah, great having you on here, and we're looking forward to what you have to say about predictive maintenance and kind of some of the solutions that you might have for some of our audience.
Absolutely. Thanks for having me, Pepper. I really appreciate it. So I'm going to get started on the presentation unless there's any other questions. Fantastic. All right. So today we're going to be talking about just kind of a general overview of what predictive maintenance is and kind of look at, basically how predictive maintenance helps out from a maintenance perspective, a supply chain perspective, and a machine efficiency perspective. And then we'll go into some real world examples of how customers have implemented predictive maintenance solutions on their equipment and their machinery, right? And we'll kind of talk a little bit about, the math of how they use to justify some of these things. And we'll kind of give an overview of, like I said, the whole value proposition of predictive maintenance. So today, just to kind of start out, right, the first thing on the list is we're going to actually define what is predictive maintenance, right? We'll talk about, historically speaking, how has maintenance been done and how has it progressed over time, and what does predictive maintenance mean in the future here. How do I get rid of this thing on my screen here? Whoops. All right. So I'm going to go back. I'm sorry. I'm trying to get this little thing off of my screen so we can have more space. But we're going to talk about, like I said, what is predictive maintenance? How is it going to save you money? We're going to talk about real world examples of how predictive maintenance has been implemented at a variety of customers and in a variety of fashions, different types of applications. We'll talk a little bit about predictive maintenance's impact on supply chains. And then we'll take some questions, right? And we'll kind of give a little bit of an overview where you can ask some questions to determine whether or not predictive maintenance is right for you, and the first step of questions you would want to ask yourself in regards to that process of implementing a predictive maintenance solution. So first things first, right? Like, what is predictive maintenance? I really need to be able to get this off of my screen here. Go away. I apologize. This just kind of came up and I'm trying to get rid of it. There we go. Perfect. All right, so what is predictive maintenance, right? Predictive maintenance is a condition-based maintenance strategy that basically remotely monitors the condition of equipment using sensors, right? So to kind of go through a little bit of history in the past here, before we really kind of got into maintenance and maintenance strategy, people would just purchase equipment and they would run it till failure, right? And they would either repair or replace it after that failure event occurred, right? Basically, not really a maintenance strategy at all. You would just buy a piece of equipment, you would use it until it's all used up, and you would either service it to fix it, or like I said, you'd buy a replacement part. Really not a lot of cost to that, just in terms of maintenance, labor resources, because you're not really doing any maintenance at all, right? But obviously, once something fails, it fails big time. So, then you're waiting for a replacement part, and it just basically is kind of not really a maintenance strategy at all. So over time, equipment manufacturers would get to a point where they would suggest a time-based frequency of servicing equipment, right? This is what we call preventative maintenance, right? Where every 6 days or 6 weeks or 6 months, we would take a look at, say, a three-phase motor to determine the condition of bearing wear associated with that three-phase motor, right? We would basically be doing inspections on a time-based frequency. Now, this is a manual process. There is somebody that you would pay going around your facility to take readings on all of these pieces of equipment that you're looking to maintain, right? So it's relatively labor intensive and time consuming. And like I said, you're paying an individual to do that whole process. And, as I mentioned, it's more of a time-based frequency. So failures can occur in between these time-based frequencies of investigations, right? Of basically a maintenance or a service situation where they're going around every, let's say every 6 months, right? You could have a motor fail 3 months into a 6 months time-based frequency investigation. And so what predictive maintenance is basically moving from time-based to condition-based service, right? Where now you have actual sensors attached to pieces of equipment, and those sensors are going to be taking readings, and then those readings will have analysis done to them to determine condition and trend, such that you can predict, or should I say the machine can predict, when a failure is going to occur on that piece of equipment, right? So the whole point of this is to reduce the need for frequent inspections, because you're automating that process. And it also lowers the maintenance cost by, like I said, automating that process. You don't have to have an individual walking around your actual facility to take these readings. It's all done by basically an automated piece of equipment that's going inside of your control panel. So just wanted to make sure we were kind of defining our terms a little bit, just so when we move forward, we understand what we're talking about here. So I've heard predictive maintenance and preventative maintenance used interchangeably, and they're fundamentally different concepts. So the real question that everybody here is for is, how does predictive maintenance save you money, right? That's kind of the whole value proposition behind why this is interesting in the first place, right? So unplanned downtime, right? There was a recent survey that was done here. Things out of the way, that said that 82% of companies had experienced unplanned downtime last year, right? Now, this can vary greatly, and I've got a slide on the next page that kind of just does a very brief overview of the different types of industries and their unplanned downtime costs. But, it can be anywhere from minimum wage up to $700,000 an hour if you're, say, an automotive manufacturer of some sort. And so obviously, when you have unplanned downtime, your costs remain fixed, even though your production has fallen to zero. And so you have all these workers in the factory, you're paying them. And if your machine goes down, it's basically just all cost and no profit at that point in time. So unplanned downtime is a very large contributor to taking away from profit in that scenario. So in addition to that, maintenance costs subtract from profitability, right? That's a very manual process. You're taking, people and you're having them go around your facility, taking readings on equipment, you're paying them. And it's just a very manual process, especially for old or aging equipment and or infrastructure. And the last thing on the list is, if you can predict when a failure is going to occur, right, you're going to, eliminate any of the quality issues that might happen from a failing piece of equipment, right? If you're shooting, plastic into a mold and the heater is starting to fail and you don't get that plastic up to temperature, now you're going to have all of your runners on your injection molding filled with plastic that all need to be cleaned out, right? So it's basically a quality issue. There's a safety issue associated with, as pieces of equipment fail, there's a chance that it could either hurt somebody or destroy, infrastructure associated with your factory or facility. And then, as we kind of briefly mentioned at the very beginning of this conversation, supply, right? Supply chains are stressed. When something fails, there is a pretty significant increase in lead time relative to what we've been used to over the last couple of years. And so, again, having kind of a foreshadowing of when a failure is going to occur, any additional lead time that you get between the prediction event and the actual failure is all just, it's just icing on the cake, right? It's free lead time that you have in order to secure a replacement part. So kind of going into some raw numbers here. And again, this is just, it's not meant to be definitive, but just more like a general overview. Some of the top causes of unplanned downtime are, as I mentioned, aging equipment or equipment failure, operator error, or just a lack of maintenance due to limited resources. And you can see kind of here, it varies wildly from industry to industry, going from, say, bottled water, which is relatively cheap because your product loss is relatively low cost, all the way up to automotive assembly, where it's hundreds of thousands of dollars per hour, right? So you could even imagine, say, 5 minutes of downtime in an environment where it's costing you $700,000 an hour is a pretty significant sum of money. And so if you can eliminate or reduce that, all of that is pure profit that's back in your pocket, and your machine efficiency goes up. It's basically, free profit above and beyond the initial investment cost. And then just, again, kind of a couple examples of what the cost to replace some expensive equipment would be on the right there. Cost of three-phase motors, transformers, gearboxes, servo motors. They're all a variety of costs, and they all have lots of zeros behind them. And then that even becomes even greater with the inflation that's taken place over the last couple of years, right? So monitoring those pieces of equipment and making sure that they're in good health and good condition is definitely worth your time. Otherwise, you're going to be paying it for it as a replacement. So to kind of put this into a little bit of a real world perspective, when we were talking about predictive maintenance versus preventative maintenance today, and I'm just using a three-phase motor maintenance as an example. Today, if you're doing preventative maintenance, you have somebody that is going around your factory here on the left side. They are taking manual readings. They are doing manual inspections on your equipment, whether it's a three-phase motor or a heater or a power supply or whatever it is that you want to monitor, right? Some machine, say a CNC machine that has a insulation resistance problem on all the servo motors, right? These are very time-consuming inspections, and like I said, you're paying skilled labor, which is kind of in short supply right now. I saw an average statistic that the average age of a maintenance worker had just hit 52 years old in the United States, right? So I imagine that's probably been significantly affected by COVID over the last couple of years, and I'm sure there's some concern about availability as time goes on here. So you're paying somebody to walk around your facility and maintain that equipment, right? To basically determine its health and status and whether or not it needs to be serviced. That's a pretty significant amount of money. I think the average cost of a motor, and this is going to vary wildly from industry to industry, was about $2,000 a year. And I think this was from 2 or 3 years ago. So it's probably gone up. And then if you have to replace one of those motors, right, again, it's all dependent upon what motor you're replacing. But in this example that we were using, it was about 16 grand, right? So not cheap. And so what we are kind of suggesting in regards to predictive maintenance is moving to a much more automated fashion, right? Where you're attaching sensors to your equipment, where you are now automating the measurement and analysis of the condition of that equipment. And then you're basically automating the alerts such that you can get, real-time status on any sort of abnormalities that it detects, such that when you're supposed to act, right? The whole idea is to then service your motor when the condition has reached a point requiring service rather than just a time-based condition, right? So you are now aware of when service is required rather than just doing it in a certain time-based frequency. So kind of moving forward into real-world examples of how customers have implemented a predictive maintenance solution in a variety of applications. Here's a good example of an automotive supplier, right? So we have a global automotive manufacturer that had multiple power supplies fail in their plastic forming station, right? And of course, they were dependent, the assembly line was dependent upon this plastic coming out and going into the actual production line. So the failures of those power supplies ended up causing unplanned downtime in their plastic forming station, which ended up affecting overall production, right? It became such a large enough impact that it was actually brought up to the management of this company such that they were basically told to figure out a way to fix this, right? Now, if somebody tells you, how do we fix where items from failing, right? There's not really a solution for that. The best case scenario you can do is just basically predict its failure, right? You can have some semblance of when you think it's going to run out of useful lifetime and that you can replace it right before it fails. So this company researched and replaced their standard power supplies. Now it's power supplies that were able to monitor the actual health and status of those power supplies and using Ethernet IP to have that monitoring done remotely as well. such that they were allowed to see the condition of those power supplies, and have an understanding of when it was reaching its failure point, right, within, say, a 6-month window or so. So after they did this, they replaced all their power supplies. They had an understanding of when those power supplies were nearing their end of life. And they had such a great success in doing this that all the other associated groups that they had affected with their downtime ended up replacing their power supplies as well with monitoring power supplies, such that they then knew when those power supplies were nearing their failure point and would replace them before a failure would happen when, scheduled downtime, scheduled maintenance had occurred. So when they looked at their initial investment costs of the cost to replace all those power supplies relative to that cost of unplanned downtime and all the cascading effects that they had, they had determined that their return on investment was about 18 months in regards to that, which is a pretty decent return on investment time frame, right? So beyond the 18 months, it was all additional profit in their pocket as a result of not having that frequency of unplanned downtime that they had calculated. So just kind of taking that real world example back a little bit to say, well, where else could you use predictive maintenance in regards to power supply monitoring? Well, this one's pretty broad and pretty general because it's basically anywhere that has power being run, right? So, pretty much anywhere, in the automotive industry, food and beverage, infrastructure, digital, any place that uses a power supply could benefit from power supply monitoring, or should I say a power supply that has the ability to tell you what its current condition is and current status, such that it advises you when you're approaching a failure point or you're approaching the end of the useful life of the power supply, right? So just like I said, basically anywhere where power supplies fail, and that causes unplanned downtime, which is pretty broad and very, very general because everywhere uses power. So moving forward, kind of to get a little bit more specific into, say, three-phase motors, there's a couple different failure modes on three-phase motors that are most common, right? And so a lot of the time we talk about bearing wear, right, which you would monitor through a vibration and temperature monitor solution. There's overloading the motor, or having some sort of chain drive misalignment, which would basically cause an overload in the motor system, which you could monitor through the current draw on the motor. And then the last one is insulation resistance breakdown, right? Which is kind of what happens over time when you're using motors in some sort of hazardous environment or non-ideal conditions where perhaps you have, a lubricant that's aerosolized and it collects on these motors, and, it's just kind of vibration and temperature and harshness over time tends to break down the insulation on these motors. So kind of going into a little bit of just broad general detail on three-phase motors, typically used in material processing applications or anywhere that you've got pumps, right, where you're moving liquid from one place to another. So wastewater facilities or anything that's got a gas where you're moving it from one place to another, kind of a compressor, material handling, fans, compressors. Basically, three-phase motors are used pretty much everywhere. And I've just got a little bit of a chart here that kind of shows the breakdown on average of just how many motors there are in the United States on average and kind of how many hours they operate on average. And so, I'm not telling anybody an unknown secret here, but we have lots of motors across the United States used for a variety of applications. They all have different costs. And so anytime one of those motors goes down, your machine efficiency goes down as well, since you're not having it up and running, right? So just kind of some context there. And so getting into an actual real world scenario where a three-phase motor monitoring for vibration and temperature was implemented, there was a hospital in Canada that basically had a lot of HVAC system failures. The fan that was basically blowing all the air through their Canadian hospital had failed multiple times. And it actually caused a problem in one of their biomedical research centers, right? That ended up having them lose a research sample that they were working on. And obviously it was kind of a big deal. It's one of those situations where it was brought up to the facility where they're like, hey, this had a major impact on what we were trying to do. How do you guys fix it, right? So they determined that they were spending about $2,000 a year in motor maintenance, and that their cost to replace a motor was about 16 grand. So after discussing it with the actual maintenance team at the hospital, they implemented a solution for remote vibration and temperature monitoring on the three-phase motors that they were using to drive the fans of the HVAC system. So by implementing that, they were then able to determine the health and condition of the bearings that were used to drive those three-phase motors for the air conditioning units, the HVAC systems. And they were able to monitor that whole thing remotely from a remote location, such that they didn't need to be on site, or they didn't need to be, walk into the room to determine health and status, they were actually able to do the remote monitoring, which I'll show on the next page here in just a second, from a front desk, right? Basically integrate and automate that whole solution where it was kind of a non-cost for them. So when they did the initial investment on these 3 air handling units relative to their cost of investment, they determined that their return on investment was 15 months after the investment cost, right? So this is kind of a little bit of a picture here in terms of showing what this looked like, where they've got, as we mentioned, kind of the vibration and temperature monitoring and this actual casing of the 3-phase motor housing here. They have this great big fans that they're using to drive the ventilation system in the hospital. And then they have the actual monitoring units that they put in a little clear control panel here so they could see status. And they also had Ethernet IP where they were able to remotely monitor the status of all these analyzers right here in a different location, right? Basically on the other side of the hospital. So they didn't need somebody in this maintenance room to be able to get live status and feed, right? And then they had some alerts and alarms that they had programmed in there. So once vibration reached a certain level, it would notify them. They would know that it was time to go check it out and determine if service was needed. Most of the time that is in fact the case, right? So where would you see 3-phase motor monitoring, right? Just in a variety of other applications. Well, anywhere that you've got 3-phase motors, obviously, and I know that's kind of a self-referencing statement here, but basically anywhere where you have pumps, right, where you're moving liquid from one place to another. So that would be like a municipal facility where you're doing wastewater treatment or any sort of liquid that's being moved from one place to another, whether it's milk or soda or water or, like I said, any sort of liquid that needs to be moved along a process, right, where you're moving it from one place to another, or even bottling it where you're going to have a pressurized liquid being kind of squirted out into a container of your choosing. So cooling towers, right? That's another maintenance facility. Hydraulic pumps, chillers, well pumps, right? Any sort of fan application for an HVAC system, whether it's an exhaust fan or ventilation or air handling unit. A lot of food and beverage, right? Where you're doing basically mixing equipment or storage tank mixers, right? Basically where you've got something that's just going at a steady state speed where you're having some sort of mixing happen, or any sort of conveyor belt or drive system where you're, moving things from one end of your process to the next, right? Where you're moving things down, you'll typically see a 3-phase motor in that sort of process, right? So wide variety of applications where you can see the use for a 3-phase motor. So now we'll kind of talk a little bit about insulation resistance monitoring, right? Now, there's a couple different styles. You could do 3-phase motor monitoring, single-phase motor monitoring, or even servo motor monitoring. And I've kind of condensed all of these different applications into one here. But here's a real-world example of one of our Japanese partners. Since Omron is a Japanese company, we've got a lot of interaction with a lot of Japanese automotive suppliers or automotive manufacturers, where they had multiple failures of motors inside of their production facility. And it came up on one of their lists of, basically what are our reoccurring problems that we keep having. And they had failures inside of their CNC manufacturing machines. They had a gantry crane that had a motor fail in regards to insulation resistance. And then they also had a injection molding machine that had the insulation resistance on the heater fail as well. So they had looked at all this and they said, how can we fix these problems? How can we at least predict when these failures are going to occur, especially if it's not a very easily accessible motor, right? Like that one in the gantry crane. And so they determined that there are insulation resistance products out there. They had implemented those insulation resistance monitoring products across their entire factory and automated the whole solution such that they were then able to tell when the insulation had degraded enough such that it needed to be serviced, right? I wasn't able to get the actual return on investment of initial investment versus what they calculated their return on investment to be for this application, since the resources that they were using, those labor resources that they were typically using in this application, they actually pulled and dedicated towards other projects that they needed them on. So unfortunately, wasn't able to get the math on this one, but it kind of shows you a real world example of 3 different types of applications within a single facility where I think this was actually Nissan that implemented this in their Japan facility. So very, very interesting application. So where would you see insulation resistance monitoring? Pretty much anywhere we got motors, right? That's kind of hand in hand with that 3-phase motor vibration and temperature monitoring is basically anywhere where you've got wires that you're really worried about the condition of their insulation is if they break down, that motor is no longer functional, or it could even potentially cause a fire of some sort. So good place to look for insulation resistance monitoring. So moving on to thermal monitoring, again, a Japanese automotive parts supplier here, different facility, right? But they had a paint station where they would use heat, obviously, to accelerate the drying of paint on the components that they were selling into the automotive industry. This is a relatively old building, and so they would have to vent that heat up into the, outside of the building, into the atmosphere. They have insulation around all the venting and all the ducts, and that insulation was deteriorating over a long period of time since it was an older facility. It had deteriorated so much that some of the heat actually started to leak out of those vents, eventually causing a fire that you kind of see on the right side right there. So the response to that was, well, we've got to hire somebody to go around the facility and manually take, thermal condition readings across all of these vents of concern. It ended up being $2,500 an inspection. What they were doing every 3 weeks, it was 45 grand a year cost, right? That's the percentage labor that they determined they were paying this gentleman relative to other work he was doing. And so they looked for a thermal monitoring system, a thermal imaging camera system, where instead of paying somebody to go around the facility, they would just get these cameras that they would basically put in these areas of interest. And then, like I said, automate the whole process where once a temperature exceeded a certain level, they would get a notification and they would know that that area of ductwork had their insulation deteriorate to such a condition that it would need service, right? So very novel way of them automating what was otherwise a manual process. And so the same thing kind of implies for any sort of thermal inspection that they're doing on control panels or any sort of other application where heat is a primary concern, and that what you would find is when the heat level continues to rise, typically what's going to happen is a fire or some sort of thermal condition event that's going to cause destruction and, quite frankly, chaos when things light on fire, right? So fire is always a bad thing. So we were able to get the math on this one. They had actually installed 50 cameras around their entire facility and 2 of these actual monitoring units associated with it. And so they were able to automate the entire process of thermal condition monitoring across all of their insulation vents. They calculated their return on investment to be 18 months in this scenario, right? So very profitable situation for them where they were otherwise paying an individual, and they were able to automate that portion and send this guy who was doing these individual thermal readings for other tasks that they needed him for. All right, so where else would you see thermal applications, right? Well, like I said, anywhere where heat is a concern, right? Where when a failure occurs, you're typically going to see a heat level start to rise all the way up to a point where things start to light on fire. So there's a statistic that I read a little while ago that there is on average 37,000 industrial fires per year in the United States, with an average cost of about 80 grand per fire, right? So it doesn't take very many of those to really get to a point where automated monitoring of thermal condition justifies itself if it prevents a single fire or even less, right? And there's some features and functionality where it can actually start to predict when a thermal runaway condition happens, giving you up to an hour in advance of notification before things start to light on fire, right? So very big deal, very, very easy way to justify safety and prevent damage, injury, and destruction of equipment and facilities, right? So very easy way to do that. Where else would you see it, right? So basically anything inside of a control panel that's generating heat, right? So power distribution, power generation, contactors, relays, VFDs, when these things fail, sometimes they go into an overload condition where they'll start to light on fire. Hydraulic presses, any sort of keep out zone where you want to make sure that you don't have people in an area, injection molding equipment, right? Something where, again, it's like precise temperature control of the equipment is critical. And if you don't have that, the equipment will either melt or light on fire or destroy or hurt something else, right? Big concern there. Even like data centers would be another place where, heat condition is critical, where if you get too hot, things start to fail and don't function. And those critical failures have a large cost associated with them, because if you're not running internet traffic, you're breaking your contract, and that's costing a lot of money. So pretty unique application. So next up, and this is the last topic that we're going to talk about in terms of real world scenarios, is heater condition monitoring. This is actually kind of a newer product in the industry right now. And I'm actually going to use an Omron specific example. This is actually our relay manufacturing line over in Omron, Shanghai. So we've had, just like the rest of the industry, we've had a lot of demand and not a lot of supply, as I'm sure everybody on this call is probably well aware, and the rest of the industry is having the same problem. So in order to maximize our throughput on these relay production lines, right, we started to look at how do we automate all of the individual pieces on this line that fail. And in our relay manufacturing line, there's a solder process that uses a resistance heater in this actual process. And so we were able to implement resistance heater condition monitoring on these solder stations on this relay manufacturing line, such that we were able to predict when these heaters used in this relay manufacturing line were about to fail, right, and go line down, and then again affect our throughput that we were trying to run three shifts of maximizing production on these relays, right? So what we were able to do after implementing resistance monitoring on these heaters on the soldering used for these relay lines is they were able to look at the trend of resistance monitoring over time in this lower right-hand corner right here. They were able to determine that it was going to be about 23 months before these resistance heaters were going to need to be changed out and serviced, right? So they were able to schedule 3 shifts of production and basically operate that machinery 24/7 without concern for any sort of unplanned downtime from failures on these soldering stations. And our return on investment from that investment was 13 months as a result of that. So really cool way to see how, you know, the company that actually manufactured this heater condition monitor has implemented on their own manufacturing lines within their manufacturing facilities. So really, really interesting way to kind of see how that works together. So basically, where else would you see any sort of heater monitoring applications? Well, anywhere we're using a temperature controller, and you know, obviously unplanned downtime is pretty something that you really want to consider the cost of, and especially if, you know, if a heater starts to fail, that you would then start making either bad product or the product that is being in the thermal process has to be scrapped as a result of, right? So automotive is typically first on that list when you think about like all of the things that need to be work hardened through a heat process, camshafts, pistons, you know, any sort of gearing inside of a transmission where the metal needs a strength component, an additional strengthening process, where if it doesn't go through the right profile because your heater is failing, those parts that are in that process end up having to be scrapped, right? That's a prime application for something like this. Along with digital, right? You think about how precise the temperature must be when you're manufacturing semiconductor chips, you know, and if you lose control of your heater or your heater starts to fail such that it doesn't have a very precise temperature control, all of those chips that are work in process ended up getting scrapped, right? And so that's a very large cost for all that value add that's happened up to that point in the manufacturing process. So this is also true for, you know, any of the ovens used in EMS, right? Like SMT or reflow ovens or anything like that. And then this is actually a personal one of mine, is a reliability test chamber. We were having to do an accelerated life cycle test on a part, and the chamber that it was in had to have it at an elevated temperature, ended up failing 6 weeks into its 8-week test process, right? So that whole process ended up having to be reset. We had to restart. It took us 20 weeks to get that whole thing finished. And one of these products would have addressed that, right? So they basically would have known when that heater was reaching a failure point, and they would have been able to change it out before it caused an issue. Food and commodity, right? You know, I think of pasteurization or something, again, where it's like, if you've lost that thermal profile and you weren't able to reach the right temperature because your heater was nearing its failure point, you know, a lot of that product ends up having to be scrapped or lost or just thrown out. And then of course you have the unplanned downtime associated with that as well. Any sort of life science where heat or, you know, an autoclave opportunity would be something where heat is a priority and it must be a certain temperature in order to make sure something is sanitized. That would be another example of where you'd see something in regards to heater monitoring. So last here, I just kind of wanted to talk about, like, okay, I've gone through a lot of stuff and it was meant to kind of give a wide overview of real life applications. You know, what would be the process that you would want to go through if you thought predictive maintenance was right for you? Well, you know, the first thing to do is obviously identify what it is that you want to monitor, right? What are the critical assets that are going to require frequent maintenance, right? So we've covered a lot of different types of equipment on this call, but you know, it's just a question of what's most important to you, what's most contributing to your unplanned downtime and or product loss right now. So when you do that, you identify those things, then you just say, okay, I'm going to find a solution for that that's going to be able to monitor that actual condition. And you obviously install monitoring devices on those pieces of equipment to make sure that you're getting data from those to determine, when is the right point to service it. So typically, a lot of these pieces of monitoring equipment have software that come with them as well. So you can automate the whole process. You can put alerts and alarms in there. When it goes above this condition, I want you to turn on an indicator light, or I want you to send me, a message over to my software that's running on a computer on the other side of the building. The whole intent then is to establish baseline acceptable conditions, right? So the way that a lot of these things work is simply measuring the initial state versus the current state and the degradation associated with that, right? So three-phase motors are all different, right? And so you can't necessarily say, all right, I'm just going to install it on a three-phase motor and they're all going to work the same. It has to establish what does good look like, and then it compares good versus current to determine status and whether or not service is required. And then from there, you set warnings and alarm thresholds like I kind of talked about. So when the baseline condition reaches a point where it's degraded, then you have an alert that's being sent to you. And lastly is when you get those alerts, you just schedule maintenance once that actual condition is exceeded, right? So that's kind of the predictive maintenance in a nutshell here. And, we actually have some additional content on Omron's website to talk about this in a little bit more detail on some of the solutions that we have. But the whole point is just basically remote condition monitoring and analysis with the intent of automating what was otherwise a skilled labor process, right? So you are eliminating the need for skilled labor of taking measurements and then analyzing those readings to determine condition and trend. That whole process can be automated, and then have ease of retrofit of these pieces of monitoring equipment onto existing pieces of equipment. So you don't necessarily have to buy it new that way from a equipment supplier. You can retrofit on these machines yourself, but obviously it would be easier if it was integrated into an OEM. That's kind of an opportunity as to where you could sell a lot of these things. So the whole intent is to reduce unplanned downtime, reduce your maintenance costs, reduce your skilled labor resource requirement, and to limit or eliminate product loss associated with unplanned downtime as well. And that's it. That's my presentation. I'm happy to take questions or any other comments that people may have.
Yeah, that's great, Dan. You're talking about thermal monitoring. One of our customers actually has their own fire department, and I think that they probably need a on-demand copy of this webinar. I'll send it to them, which I will also send to all of you people that are on this call. I'll send a link to an on-demand video of this webinar that you can pass on to some of your teammates if they weren't able to make it. And also I will offer up the slide deck as well for you guys to use to educate your team as well on predictive maintenance. I do have a couple of questions in the chat box. So how do I prove to my boss that predictive maintenance brings value?
Well, so, this is going to vary on each customer's basis, right? The whole point is to basically address unplanned downtime. And so the whole process that you would go through is to say, all right, how much unplanned downtime have I experienced last year, right? And which pieces of equipment are the ones that have contributed to that unplanned downtime? And then obviously your next question is are there any devices out there by any supplier that have the ability to monitor that piece of equipment, such that I can automate the monitoring, the measurement, the analysis, and it'll actually tell me when a failure is going to be imminent, right? So from that, you can determine your unplanned downtime cost on a yearly basis, and then look at what's the investment cost in order to automate that and turn it into a predictive maintenance solution. And then, it's just kind of gets into a accounting and financial department at that point, where you can say, hey, if I have a $10,000 investment, I'm just making up numbers here, $10,000 investment, and it's going to save me $15,000 a year, that means that you're going to be saving $15,000 a year, basically 9 months into the year. And so, your math starts getting pretty easy to make these things work in terms of saying, all right, maybe we're not selling more product, but if we can make our product being produced more efficiently and our machine utilization gets up to as close to 100% as possible, it's just kind of one of those things where, it doesn't really matter if you're selling more product. It matters how much more efficient your actual production process is, right? This is one of the things that I actually was really good at my previous career in a different field, was understanding your cost of manufacture, right? And what you could do to decrease your cost of manufacture. You know, there were some years where revenue was down and my profit was still up just because I made sure that our cost of manufacture was going down every year through a variety of means, either it's supply chain or machine, efficiency, or just, automation of a variety of steps in the process, right? It's kind of one of those things where it's revenue agnostic, if you know what I mean, right? Even in down years, if you're building widgets more efficiently and more cost effectively, that's just a benefit across the board, right? It doesn't necessarily matter how much revenue is coming in, either more or less, if you're producing things more efficiently and your cost to manufacture is lower.
Thank you. Steven says, thanks a lot, Dan. Great presentation with nice demos. Would it be okay to share a copy of the slides, probably with Steven's team?
Absolutely. Yep. So Pepper, I'll make sure that you get this presentation after this call is done, and you're free to distribute it as you wish.
Okay, great. And then Soyab says, do you use machine learning for predictive maintenance currently? If yes, can you talk briefly about in what way it is used?
Sure. So this is kind of a larger topic, and there are some things that I know, and there are some things that I don't know. So we have, at this point in time, we have 7 different pieces of equipment that monitor different pieces of equipment and the failure modes associated with them, right? So just to kind of give a little bit of clarity on that, we have 3 different products that monitor failure modes for 3-phase motors, right? And so they're all monitoring a 3-phase motor, but it's 3 different failure modes within that 3-phase motor. Where machine learning comes into play is kind of where the predictive element of it is, right? Where it starts taking readings over time and it looks for variations in that readings, and it basically kind of looks for what is good versus what the change has been, right? And there is some predictive elements inside of our chips that are used in these monitoring devices where it's able to determine, when a abnormality is showing up. Same thing with that thermal imaging system where it actually has an ambient temperature sensor in the camera, and then it's able to look at something that's having a temperature rise, and it's able to predict what the future steady state temperature will be because of that ambient temperature. And then it'll say, hey, if there is an alarm that you've set that is below that predicted temperature, I will alert you in advance of the actual failure. I'll be the first person to tell you that I'm not going to be able to get into the actual logic in the software in terms of how machine learning is used in the actual programming of the chip. It's more along the lines of what is the output of machine learning in terms of how is it functional in detecting a predicted failure, right? I was not the designer of the product, and so I'm not sure I'm going to be able to communicate on a level that's going to get into the, I guess I would say, the design logic of what's used in the chip to detect those, to predict those actual failures. So that might not be exactly what you're looking for. It's kind of my level of knowledge on the matter, though.
Okay, we have one more question come in, and Dan, thank you for getting us over the finish line in 39 minutes. We always say that these will go 40 minutes, and then any questions, people can stay as long as they want. So thank you, Dan. Said, you talked about all these solutions. Where is a good place to start?
So Omron has a website with predictive maintenance solutions on it. We've got kind of our own little page that kind of talks about it. And then IDM also carries a lot of our products, and we work very closely with them as well. So if you have a piece of equipment that you've been thinking about or that has been causing you problems, or if you're just kind of looking to know a little bit more, there's also some content on YouTube when you've kind of, like I said, narrowed it down to a specific piece of equipment and a specific condition that you're trying to monitor, right? They all kind of do different things. We've got, like I said, thermal condition analysis, heater condition analysis, 3-phase motors, power supplies, insulation resistance. And so they all kind of have their own different knowledge base and use case. And so the first place that I would start out is basically determine what it is that you're trying to monitor, right? What are you having a problem with, and what are you trying to monitor? And then kind of go from there, right? Get a little bit specific in regards to the type of product that you're trying, or type of equipment that you're trying to monitor. Otherwise, predictive maintenance is a lot of individual solutions. There's some suppliers out there that kind of use the web service where, you can get their sensors for cheap, but you have to use their software on a monthly subscription-based fee. And then it's also, are you going to predictive maintenance solution your entire factory, or is it just one piece of equipment? Are you kind of going on a piecemeal basis, or Are you building a new factory and everything from the start's going to be, having a predictive maintenance solution to it, then integrated into a larger system that's using a PLC? So, that's a very large conversation, and it's going to be unique for each customer in regards to what it is that they're trying to prevent a failure on. That's probably 2 or 3 more webinars in and of themselves on the specific use cases of each of those things, right?
Dan Anderson with Omron Americas, thank you so much for your time, and for everybody that's on the call, congratulations on furthering your education today.